Hello everyone. In the past couple of sessions, we have understood in detail about what integer position based indexing is and what label based indexing is, which we also have called as implicit and explicit indexing respectively. We again have dealt with extracting specific records of a particular data frame, also looked at deriving specific columns of a particular data frame, but we have not truly dealt with data subsetting in data frames, which is like to extract specific rows as well as specific columns, like subset the data both based on rows as well as columns here. So let's try and understand on a very foundational level on how we have implemented data subsetting in our NumPy arrays. So let me create a NumPy array first, a two-dimensional NumPy array, which I am calling it as ARR2D, making use of np.arrange function, providing 48 within the parentheses, also reshaping it to have a size of 8 by 4, 8 by 6, that is 8 different rows and 6 different columns here. I'm just trying to print the array as well. So we clearly understand that this is a data. This is a two-dimensional representation of an NumPy array where the row indices begin with 0, 1, 2 and so on till n sub r minus 1, n sub r being the number of rows here, and column indices would start from 0, 1, 2 and so on till n sub c minus 1, where n sub c is being the number of columns that are available within this particular array here. Okay. Now let's consider a particular scenario where I am planning to retrieve this specific subset data, the one that I have encircled now, that basically would have row indices of 0, 1 and 2 and column indices of 1 and 2. So how do we deal with this problem? So we basically consider this array 2D within subscript notation. We are providing row indices of 0 colon 3 and column indices of 1 colon 3 in order to extract the data. The row indices as well as column indices both are implicit indexes here. The implicit indexes being the indexes that start from 0, 1, 2, 3 and so on till n sub r minus 1, and column indices 0, 1, 2 and so on till n sub c minus 1. These are implicit indices. So we just have provided the row indices as well as the column indices. So we always know that the end index is always excluded. So and hence we are looking at 0, 1 and 2 data specifically when we are talking about the row indices, and 1 colon 3 would only consider 1 and 2, index 1 and 2 positions and not 3 here because this is the end index. So this is how we have subsetted the data. Let us consider the same array and try and create a data frame out of it. So pd.dataframe is going to help us create this data frame object by providing array2d within the parentheses here. If you inspect the data frame, we clearly understand that we are having row indices as well as column indices here. So we do not have any labels or column names that are provided to this particular data frame yet. So let us consider the same code where we have implemented data subsetting for arrays. Just replace this array2d with df, and this here is prone to an error. So we cannot go about deriving subset data based on the row indices and column indices that are provided together. So how do we slice this particular data, or how do we extract this subset data both at row level as well as at column level? So when we want to extract specific rows and specific columns within the data frame together, so this is not how we approach the problem. We would use a couple of methods called .lock and .iloc methods specific to data frame object. So .lock method is label based indexing method. Iloc is integer position based indexing method. So we'll understand the difference between these two here now. So .lock here is going to be, .iloc here is going to be integer position based indexing. We clearly know that all of these that we are currently observing are nothing but integer position based indices. So obviously 3 is being excluded now when we select the specific rows, and 3 is being excluded from the column indices when we select the specific columns here. So this data, the resultant subset data that you are currently observing, matches exactly with the NumPy array subset that we have derived earlier. If we are changing this iloc to lock, then you are referencing explicit indices, or you are referencing labels, and you're no longer referencing the integer position based indexing. And hence this 3 is included. So 0 colon 3 here are not implicit indices anymore. They are nothing but the labels associated with the data frame. So 0 colon 3 will actually derive all these row indices, like including 3 itself. 1 colon 3 also includes 3 because these are not implicit indices. So these are nothing but the labels. So whenever you are using .lock, it actually indicates that we are looking at providing labels and not integer position indexes here. Okay, that's the key distinction between iloc and loc. Let us consider the stored df data that we already have created in the previous session and try and understand more about it. So now I would want to subset this data by only considering these first three records and specifically looking at number of items and location. So whatever area that I'm currently highlighting is the subset data that I'm planning to derive now. So let's consider storedf.loc. LOC is label based indexing. So labels are nothing but 0, 1, 2, 3 and so on till 6 here. So let me provide 0 colon 2. 2 is included here because we are using dot loc method. Dot loc method does indicate that we are providing labels and not implicit indices here. The number of items and location are nothing but the column indices or column labels to be more precise. We cannot call them as indices. The number of items, comma, location is going to help us deduce only the subset data specific to those two different columns. And all of these rows where row labels are starting from 0 till 2 being included, since we are not talking about the implicit indices anymore. If I'm going to change this particular statement in a way that I am now implementing .iloc and not loc. So you're not supposed to provide labels anymore here. Since iloc actually signifies that you are supposed to provide column indices and not column labels. Okay? So integer position based indexing is now the approach that we need to take. So let's consider these column indices, labeling these column indices 0, 1, 2, 3 and 4. Now we are supposed to get column index 2 as well as column index 3 based upon integer position based indexing operation that we are currently doing. So 2 colon 4 is what we need to provide because 4 gets excluded. If you are giving 3, 3 gets excluded, but our result should include 3 as well. That is a location column as well. So this is how you extract the data. Since you are providing integer position based indexing here, you need to provide 3 so as to derive this particular record as well. I believe that you have understood the clear distinction between usage of .loc method and .iloc method. So using .iloc, we are always considering integer position based indexing to be done here. And using loc, we are always considering the labels here. So in order to understand a little better about the labels that we are supplying here, let us look at updating this particular storedf index values. So I'm updating the storedf index values from 0, 1, 2, 3 and so on till 6 to A, B, C, D and so on. So let me write a simple list comprehension like I for I in range of 65, 65 is the ASCII value corresponding to capital A here. So 65 plus 7. 7 will be the number of observations that are currently present in my data frame. So I am enclosing this particular I, which is nothing but the value that we are reading from this range object within the parentheses of CHR function. And once we do this, I'm also trying to display what the storedf contents are in the next step. So let's run this particular code. Now we no longer observe the labels to be 0, 1, 2, 3 and so on till 6, but rather we are now observing these characters as labels. So you still can consider applying .loc by providing the indices or labels to be more precise, starting from A till C, C being included. We also can provide these columns that we are planning to retrieve within the result. So number of items and location are the columns that I'm looking for. This is what the data would look like. You still can perform the same operation or retrieve the same subset data by providing iloc, but this time you cannot provide these labels. You need to provide integer positions. So 0 colon 3, 3 now gets excluded. And obviously you need to provide 2 colon 4 here for column indices that are to be retrieved, and you get the same result now. Okay. So we have pretty much covered about how you perform data subsetting for a particular data frame object that we must have already created. We use 2 different approaches. One of the approach is using .loc method, where it considers label based indexing approach. And the other approach is going to be iloc method, where it considers integer position based indexing while performing row slicing and column slicing together. Okay. So that's all in this particular session, and thanks for watching.